might have heard of the word pendulum, which is a body suspended from a fixed point so that it can swing back and forth under the influence of gravity that acts downwards. There are two types of pendulum: physical pendulum and simple pendulum. Simple pendulum is an idealized version of a physical pendulum in which a point mass is attached to a light inextensible string and suspended from a fixed support. Obviously, in macroscopic world, there is no such thing as massless string, and it's impossible for a body mass to be concentrated at a single point. However, if we take a sufficiently thin string, such as a thin thread, and a very small object slightly heavier than the string, such as a small stone or a metallic ball, we are close to having a simple pendulum. We'll assume our setup to be simple pendulum anyways. The object attached to one end of the string is known as the bob of the pendulum. Initially, the pendulum is at rest. This position of the pendulum is known as the mean or equilibrium position. So what will happen if I give a bob a little push in either of the direction? The bob will start its movement towards the extreme position A. It's the position with the maximum amplitude for a certain length of the pendulum. Then the body will move to another extreme position, that is point B, and it will continue its to and fro vibratory motion unless influenced by air resistance. How is simple pendulum a type of simple harmonic motion? In a simple pendulum, there are two forces acting on the mass at position O, the weight and the tension in the string. So this force of gravity has two component forces, mg cos theta and mg sin theta. Notice that theta is merely the angle that the string makes with the imaginary y-axis. And now see that there is no motion at position A, which means that mg cos theta and tension in the string are equal and they are cancelling each other. But we do have a net force acting on the mass at position A. But that net force is directed towards the mean position, which is mg sin theta. So this is the force that creates our oscillatory motion. It is also known as the restoring force. So Fr is equals to minus mg sin theta. This shows that the restoring force is directly proportional to the displacement from the mean position, and it is always directed towards the mean position. That is why simple pendulum is a type of simple harmonic motion. Time period for the simple pendulum. Time period is the time the simple pendulum takes to complete one full cycle, from the mean position O to the extreme position A, and from the extreme position A back to the mean position or the equilibrium position O, from that to the other extreme position, that is extreme position B, and from that extreme position B back to its original position or the mean position. This is known as one cycle of a simple pendulum. The formula for finding the time period of a simple pendulum is the product of 2 pi, which is considered as constant, with the square root of the ratio of the length of the pendulum to the acceleration due to gravity. That is, time taken is equals to 2 pi under root L by G. The time period doesn't depend on the amplitude and mass of the bob. This is because when the amplitude increases, the velocity and the restoring force also increases, which takes an equal amount of time for the pendulum to oscillate. Same is the case with mass of the bob. If the mass of the bob increases, the vertical component mg sin theta also increase, making the restoring force greater. Thus, due to the increase in restoring force and velocity, it will take the same amount of time for the pendulum to oscillate. Hence, we can say that the time period of the simple pendulum directly depends on the length of the string. When the length increases, the time period will automatically increase, and vice versa. And it is also inversely proportional to the value of g, which is acceleration due to gravity. The greater the gravitational acceleration g, the lesser will be the time taken by the pendulum to oscillate and vice versa. Applications of simple pendulum. The most common use of simple pendulum is in the pendulum clock. A pendulum clock is a clock that uses a pendulum and a swinging element as a timekeeper, where the energy is converted back and forth. As it accelerates towards its lowest point, its potential energy is converted into kinetic energy. And as the bob climbs up, the kinetic energy is converted back into the potential energy in equal intervals of time. You can understand this concept easily by the diagram given below. At the extreme position, the potential energy is at maximum. When the bob moves towards the mean position, the kinetic energy becomes maximum because of the maximum velocity, where the oscillation takes place in equal intervals of time. Quiz time! Why do we have to wind the pendulum clock every now and then? The answer to this question is in the description box. But before checking, test yourself honestly. Simple pendulum is called so because it's an ideal system with a massless string and a point mass oscillating in periodic motion about its mean position, where the restoring force is provided by the vertical component of weight mg sine theta, with the time period of one cycle b is equals to 2 pi under root L by g. I hope you now know about simple pendulum, factors affecting it, and the time period. If you did, like and share this video with your classmates and subscribe for more such videos. Smartitute. Learn fast, adapt well.